right, folks, this is lab 10, the inference for many means, or ANOVA lab, and this is the tidy version. So like always, I've sent you a Canvas announcement that has the Prelab R Markdown, and you need to download that onto your computer and upload it to RStudio Cloud in order to work on it. Of course, we're starting off by loading our packages like always. So I'm gonna library tidyverse and library infer, and then click the play button. Great, and then I need to load my data in, and I could control enter there to run that line of code. It's the same data that I'm always using. So in past labs, we've done inference on a single mean, and we've done inference on two means, a difference of means, and now we're gonna do inference on many means. We're gonna use a procedure called ANOVA, that stands for analysis of variance, and we're going to be comparing variability within groups to the variability between groups. So when we're doing ANOVA, we're only going to do hypothesis testing. That's the only inferential task. There's no confidence intervals until we get further. There's some confidence intervals for the inference after ANOVA, but for the stuff that kind of goes with chapter 8.1, it's just hypothesis testing. And our hypotheses are always the same. The null hypothesis is always mu1 is equal to mu2 is equal to ... all the way out to is equal to mu k. And the alternative hypothesis is at least one of the means is different. So for this pre-lab, we're going to consider the variables marital status and number of hours worked last week. So we're going to have a mean of number of hours worked last week for each one of the different marital statuses. So I'd like you to try to make a set of side-by-side box plots to show the relationship between these two variables. And I'd encourage you to pause the video for a minute and just see if you can figure it out on your own before you go on. All right, I'm gonna do it. So we're gonna do a ggplot of that GSS. Then outside the parentheses, we're gonna put a plus, and then a geom underscore boxplot, and then parentheses. And then we need an AES with parentheses. Our X is gonna be marital underscore status, and our Y will be number underscore of hours worked last week. And then we could control enter and it'll run it for us. So here's what my box plots look like. So it looks like maybe there's some variation in the number of hours that people work. In particular, it seems like people who are widowed are maybe working less hours than people who are divorced, married, never married, or separated. There's something going on with the separated. That box looks pretty different to me. But again, we're going to use statistics to tell us if these are statistically significantly different. So the first question is, how many groups do we have here? We have 1, 2, 3, 4, 5. I'm not going to count NA, so I'm going to say 5 groups. And then we could write out our hypotheses a little bit differently if we wanted to. We could say mu1 equal mu2 equal mu3 equal mu4 equal mu5. That would be more specific. Or we could really write it out. Mu for the divorced people, the average number of hours worked, is equal to the average number for married, is equal to the average number for never married, etc. And we're going to use this built-in function in R to do ANOVA. It's the AOV function, analysis of variance. So it's just kind of like a little bit short for ANOVA, and it's going to use an F distribution for the distributional approximation to approximate that null distribution. So in order to use that approximation, we need to have our conditions met, and the conditions for the F distribution are that the data needs to be normally distributed, or all of the n sub i's need to be greater than 30, so the sample sizes in each one of the groups. And then the variances of the groups need to be equal to one another. And the way that we check this in practice is we divide SD max divided by SD min, and we check that that's less than 2. So again, I'd like you to try to check those conditions. See if you can think about what kind of summary statistic you would need to do in order to check the first and the second condition. Pause the video, try it out, and then come back when you're ready. Okay. So the first one is that all of the sample sizes for each of those groups need to be greater than 30. So the easiest way to do this is we're going to do GSS, then that's the pipe, the percent greater than percent, and I'll hit enter, and then I'm going to group underscore by marital underscore status, and then another pipe at the end of that line, and then I'm going to summarize n equal n open paren close paren. And that's the function that just counts up the number of things in each group. So if I control enter here, I get there's 403 people who are divorced in the data set, 998 married, etc. It looks like the smallest group is 75 people who are separated. So that's a pretty small number, but it's not down to that 30 or less. So we should be able to do inference. But I'm noticing that I've got some NA values here, and actually those are gonna come back later. So let's stick another line into our data analysis pipeline. Let's drop underscore NA parentheses, and let's drop it on both the variables, marital underscore status and number underscore of hours worked last week. And then I need a pipe at the end of that line so that it keeps moving along. So GSS, then drop NA, then group by marital status, then summarize. If I control enter, oh, I spelled marital wrong. Marital. Looks better. Control enter. Now we've got it. Okay, so we got rid of those 2 NAs for the marital status, but it looks like we dropped some other rows as well because some of these sample sizes dropped down. Still, all the groups are greater than 30. So all groups are greater than n of 30. Smallest is 43. So the first condition is met. And then we need to check our equal variance condition. And that's going to start off much the same way. I'm actually going to just copy these first 3 lines here, and then I'll write them again down here. So I'm going to GSS, then drop NA on both of those variables, then group by marital status, and then I'm going to summarize. And what I'm going to summarize is SD is equal to SD parentheses, number of hours worked last week. Control enter there. So now it's giving me the standard deviation for the number of hours worked last week for each of these categories. So divorced, married, never married, separated, widowed. And it looks like my maximum standard deviation is 16.7 and my minimum is 13.7. So I could just divide those 1.21. So the SD max divided by SD min is equal to 1.22, which is less than 2. So the second condition is also met. Great, so now we can do inference.